All right, chemistry kids, here's the last lecture we're going to talk about in the chemical reactions. We've talked about the types. We talked about activity series and solubility rules. We talked about single and double placement reactions. Okay, how to identify them. We talked about binary composition. We talked about how to predict products a little bit. Okay, so the more practice we get, the better you're going to be. Now, we're going to do the last thing. We're going to balance chemical equations using the law of conservation. All right, so on the last page of your notes, here we go. So really what's going on when you have a chemical reaction is you need to have the same number of each element on each side of the arrow. So you got to think of it like this. So here's my line. I got to have the same number of carbons, same number of hydrogens, and same number of oxygens on this side as I do on this side. How do we balance that out? Well, you got to use your coefficients. Okay, provided that the formulas are given to you, like for instance these ones are, all those subscripts, the formulas are good, you just do coefficients. Remember, coefficients are the big numbers that go in front. That's the only thing you change. So when you do this stuff, it's always good to use a pencil, okay, because lots of times you'll have erasers you need to do and things like that. All right, so make sure that you know what's going on with that. So here we go. Let's give it a try. So I'm going to just be very deliberate in this stuff. I'm just going to write everything out. Some people can do it in their head. Some people need it to be written out. It's up to you how you want to do it. Here's how I would start. If I don't know what I'm doing, here's how I would first start. I would make a list. Here's my carbons. I have hydrogens and I have oxygens. I have carbons, I have hydrogens, and I have oxygens on each side. All right? I have 3 on this side. I have 1 on this side. I have 8 on this side. I have 2 hydrogens on this side. I have 2 hydrogens here, and I have 3 hydrogens. Okay? So, here we go. Rule of thumb, when you're doing this, always save oxygens for last. Okay? So, save oxygens for last. Trust me, it'll work out a lot better. And I would do like your metals first. All right, so first one I would say is like, let's do carbon. All right, we know carbon's not balanced. In other words, they're not the same number. We have 3 here and we have 1 here. So the best thing to do, well, to make that even, I'll times this by 3. And that'll make this 3. So how do I do that? Well, I put the 3 here. So now I have 3 carbons. But also notice this 3 now pertains to the carbons, but it also pertains to the oxygen. So now I have 6. So now I got to take this I guess you could view it like this. I have 1 and I have 2. Now I'm going to go like this. Now I have 6. Now I have a total of 7. Okay, 7 oxygens on this side. Because I had to times that by 3. So this 3 came from here. All right, that's why I times those by 3. Because when I do the one, I have to do the other one. Because remember that coefficient distributes. Next, I would go for my hydrogens. I got 8 hydrogens here. I only have 2 hydrogens here. Well, what times 2 makes 8? Well, times it by 4. And that'll make 8. So I put a 4 here. But now, notice, there's an oxygen in there. So because I timed the hydrogen by 4, now I also times the oxygen by 4. So now that's 4. Okay, so now, so let's circle so you know where these numbers came from. Those 3 came from here. Put a box around this one, put a box around this one. That one came from there. Okay, so now, here's what we gotta look at. Now we got everything balanced. Carbons are good, hydrogens are good. Now we have our oxygen, save them for last. We look at this, say I have 2 here. I have 6 and 4, which is 10. What times 2 makes 10? And that would be the wonderful world of the 5. 5. 10. So now my reaction is balanced. In other words, it has the same number of each element on each side of the reaction. Same number in the reactants, same number in the products. 3 carbons, 3 carbons. 8 hydrogens, 8 hydrogens. 10 oxygens, 10 total oxygens. Remember, you just add those. All right? So really what you got to do is you got the same number on each side. And how do you do that? Coefficients. And just a rule, Save oxygen for last. Okay, usually go metals first, and everything else is kind of discretionary. Depends what goes on. All right, so let's try another one, see what goes on. So there's your detailed thing, and for the rest of these, I'll talk it, but I probably won't write it all out. All right, so let's try, let's say we got this one here. ZnS reacts with now, if I were to give this to you and say, complete the reaction and balance it, all right, that might come up, just so you know. ZnC3, P2, Al2, S3. Okay, so there's my reaction. So I look at it right away and I can say, well, there's no oxygen, so I don't have to worry about that. The zincs don't look good. They're not balanced. The oxygens don't look good. The sulfurs don't look good. And the phosphorus don't look good. All right, so here's what we got to do. I would just start with the first one. Why not? I mean, you could start anywhere if you really wanted to, I guess, in this one. So I have three zincs here. I need 3 zincs on this side. Well, let's put a 3 here. So now I have 3 zincs, but also I have 3 sulfurs. Okay, so I have 3 sulfurs here. I got 3 sulfurs there. That's okay. That worked out. Nice. Sometimes it doesn't. Okay, but you got to watch those. You got to kind of check and recheck throughout this whole thing. Now let's see what's off here. I have aluminum here. Aluminum's got 2. I only got 1 there. So how can I make that myself have 2 aluminums? Put a 2 in front. 2 aluminums, but also that add to the phosphorus. 2 phosphorus, 2 phosphorus. There you go. It balanced. All right. So it worked out nicely. Some of these do not work out so nicely. So you got to be careful when you're doing this stuff. All right. Let's try another one. Just for the sakes of it. Let's try one like, let's try kind of a weird looking one. Okay, so this is kind of a weird looking one, but nonetheless, it's there. All right, so don't get scared by the fact that it doesn't look like a reaction you guys normally don't do. You can still balance it. All right, remember, it's just the same number on each side. I have 2 nitrogens here on this side. I have 3 hydrogens. Well, technically I have 5 hydrogens on this side because you add those together. And then I have 1 sulfate. All right, so a good thing to look at and just say, look at this in groups. 1 sulfate. You can look at it by S's and O's if you want to, but I would only do that if necessary. All right, try to keep them in groups. It helps out a little bit. So here's the first thing I would do. Well, I need 2 nitrogens and I need 8 hydrogens. Well, let's see if we can work that out. So I need 2 nitrogens, so I'd put a 2 here first. So 2 nitrogens, 6. So here's 2 nitrogens, good. Nitrogens are good. Now I have 8 hydrogens, 6 and 2. Oh, there's 8 hydrogens. That worked out nicely. And then I have SO4, 1 SO4. It's balanced. Some are really that simple. Some are way more elaborate. All right. And let's try kind of another one just to get you looking. P and O2. All right, there's another reaction. Notice this is a composition reaction. All right, my phosphorus are not balanced. I need 2 of those. And my oxygens are not balanced. I need 5 of those, and I only have 2 here. All right, so here's what I would do. First thing I would do is say, well, let's balance the P's out, right? Because save oxygens for last is the general rule. Put a 2 there. Phosphorus are balanced. Now I have a 2 and a 5. That's going to be tough. How are we going to do that? Well, anything times 2, well, you can go 2.5 times 2, which would be 5, but we don't use half. We only use whole numbers. So what we're going to have to do, I think, is what's a common number we can get 2 and 5 and 2? And that'd be 10. So if I go 2 here, now I have 10 oxygens, and I go 5 here, now I have 10 oxygens here, but now notice I have to redo my phosphorus. 4 Just erase this one. This is why we have pencils. To be nice. 4 there. 4, 5, 2. There's my coefficients. If these numbers get too big, they should be in their simplest form. They should be reduced down. And we'll get into that. But there's 3 examples, all right, of how to balance chemical equations. Remember, what you start with on one side, you have to end with in terms of numbers. So that means the masses will balance out. In other words, weight is, this is the law of conservation of mass. Weight is conserved, mass is conserved. What you start with, you have to end with. And how do you show that? By changing the coefficients. And when you change the coefficients, the weight changes. The weight changes of the amount of compounds you use. And it should balance out. Some are real easy, some are difficult. But that's why you got to use the pencil with an eraser, because you'll be scribbling and rechecking a lot. All right, so make sure you have a pencil when you do this stuff. All right, that was the end of it. Have a good one. We'll talk to you later.